Dear students, in this presentation, we will discuss how to evaluate postfix expression. In the previous sessions, we have solved some of the things like how to convert infix expression to postfix form or infix expression to prefix form. Now, here the actual evaluation process starts. This requires certain steps. You will be given postfix expression. For that, we are going to use stack because the operation can be performed only on arrival of quite number of parameters. For example, suppose my expression is a plus b. In the previous sessions, we have seen how to convert this into postfix form. This is the postfix equivalent of the expression. In this session, we are going to evaluate it. To evaluate, we need to know the value of these variables. We shall take that value as 6 plus 7. Here the operator is in between two operands, so it is infix expression. The converted form is 6, 7 plus. Here, all of a sudden you cannot perform. The symbols are arriving like starting from left to the right. So this is the scan process. The first step is you have to scan the symbol from left to right till you get this last null character or no more symbol available in the input expression. So 6 is operand, 7 is operand and plus is operator. When I get 6, I will not be knowing what operations I have to perform. Even when 7 is arrived also, I will not be knowing what is the operation. So to solve this problem, we have to make use of stack. So initially stack is empty. As and when the operand comes, you have to push it onto the stack. So 6 is pushed. The next symbol that we are going to scan is 7. It is not an operator. I cannot perform the operation. So again 7 I have to push it onto the stack. Now the newly arrived symbol is plus. Now I got the knowledge what operation to be performed. What operation to be performed on what operand? Where are those operands? These operands are on the stack. What is operator? Operator is a plus. You perform plus on what? We have accumulated those in the stack. So first of all we need those. That is why we have to pop those top symbols. Two top, not just one, two, because it is a binary operator. Binary means it requires two operands. Plus requires two operands. 6 and 7 were there in the stack, you pop it. So plus, when the operator arrives, pop two symbols from the stack. The first symbol is 7. This becomes operator 2. Second symbol is operand. Second symbol is this second. The other pop one is 6, which is operand 1. The operator is plus, that means plus you have to perform. So that is why it is given here. If the token is operand, push it onto the stack. If the token is operator, then what to do? So remove top two elements from the stack. So here you have to use pop operation. Remove top two elements of the stack. Evaluate them. If it is plus, perform addition. If it is minus, perform minus. If it is into, perform multiplication. If it's slash, perform division, like that. For all these binary operands we need two operands, perform the operation. Then what to do? So after popping out 7 gone, 6 gone, the status of the stack is like this, no element. The resultant 6 plus 7, the result is there, right? That you have to push it for further operation. You can push temporarily or If there is no other symbol in the expression, this 13 is the final answer. We'll take one example. We have solved this last day, but with the variables. Given expression is 5 plus 6 into 7 minus 8 minus 3 into 4 plus 3. For this, first step is to convert this expression into postfix form. Okay. Now, to avoid the confusion, when to stop. So better you put one closing bracket. Remember that only one closing bracket you have to put it. Just to indicate that, just to mark that it is the last of the expression, last symbol, which we don't want to use it. Just to indicate that is the last. Now we'll start one by one. The first symbol is 7. Sorry, first symbol is 5. 5 is operand. Push it onto stack. Next symbol is 6. Push it onto the stack. Next symbol is plus. You have to pop top two symbols. The OP1 is 6 and operand 1 is 5. The operator is plus. 5 plus 6, 11. The answer is temporarily pushed onto the stack. This is 11, the temporary answer. Then it is a 7. Already 11 was there. Now 7 is going to push. The next symbol is star, operator, binary operator. Top two symbols has to be popped out. The OP2 is 7 and OP1 is 11. You have to perform two pop operation. 11 into 7 is 77. 77 is pushed onto stack temporarily. Next symbol is 8. Push it onto the stack. So 8 sits on top of 77. Next symbol is 3. 3. Right now we can't decide because operator had to arrive. So 77 was there, 8 was there, now 7 is also pushed. The next symbol is minus. So top two symbol has to be popped out. The OP2 is 3, OP1 is 8, the operator is minus, 8 minus 3 is 5. So 5 is pushed onto stack. The next symbol is 4. Next symbol is 4. Earlier it was 77 was there, previous step 5 was there, now the new one is 4. 4 is also pushed onto stack. Next symbol is 3. Again you push 3 onto stack. Right now the condition status of stack 77, 5, 4 and 3. The next symbol which is arrived is plus. So you have to pop last two symbols. OP2 3. OP1 4. Always remember that when the operator arrives, the top two symbols you have to pop out. The first pop is OP1 2, the second pop is OP1. So to avoid the confusion, the topmost symbol becomes OP2, previous to it becomes OP. Okay. The next symbol star for form operation. 7 into 5 is 35 pushed onto stack. Next is minus. 77 minus 35 is 42 and the closing bracket. When the closing bracket arrives, that indicates you have to stop. Whatever the content is there in the stack, that is the output. So 42 is the output. So this is how we can evaluate the expression. There is a lab program. We have to develop program in C using stack to demonstrate even push operation or pop operation to perform basic mathematical operations. Those mathematical operations are addition, subtraction, multiplication, division, modulus and exponentiation. So here we have got some mathematical operations like power. So math functions required. Then input output operations. We need one stack like earlier. Initialize top value -1. Initialize stack with that size, any size. Any operation that requires two operands, OP1 and OP2. The symbol can be plus, minus, star, clash, percentage and power. If the symbol is plus, perform plus and return. If symbol is minus, perform subtraction and return. If symbol is star, perform multiplication and return answer. If symbol is a slash, just check whether the second operand is 0 or not. If it is not 0, then only return. Break is not necessary because return is there. Percentage, again, second operand, the divisor is not 0, then only return. Percent and the power symbol, exponentiation. Use function pow, which is actually that returns a double answer. Typecast it into integer. It requires two operands. One is op1, op2. Suppose your first operand is 2 and second operand is 3. It is actually 2 into 2 into 2. Answer is 8. 8 will be returned, but 8 is in the form of double converted into integer. So for all other operations, return 0. For push operation, you are going to push the operand. Operand is of type integer. Increment the top value. Our stack name is s plus plus top, push the operand. In case of pop, return the top value and decrement the top value. First you pop, then decrement. Pop and decrement. Here, first increment, then push. The program goes like this. Your input expression you are going to enter through the console. So it is a string. Read the string. This is a string array. Maximum size is 20. Scan the symbol till you get the null character, the last character. Store that in symbol. Symbol is starting from I, the first character, second character, like that. Take for example, suppose my input is 1, 2 and plus. This is a simple example. This is my expression. This is my postfix expression. Postfix expression is 1, 2 plus, and here the null character starts. The symbol right now scanned, that is 1. That 1 is character. It is represented like this within the quote. The symbol is character 1. Symbol is character 1. If the symbol is in the form of character, we cannot perform arithmetic operations. You have to convert this into the normal, that is in the numeric form. To do that, you have to subtract it from 0, that is ASCII value. If you subtract it from 0, you will get 1. So that step is shown here. ASCII value of 0 is 48. ASCII value of 1 is 49. So 49 minus 48 is 1. Is 1. This is how internally that you have to do. The statement is the arrived symbol, just now scanned symbol, and subtract it from 0. Subtract it 0. So you will get the actual operand that is required to be pushed onto stack. So this is the heart of the program. Okay, so this is possible only if these are digits. That is why you check this also. If is digit of that symbol, is it a digit? That one is a digit. Yes, you can go ahead. If it is a digit, this is called ASCII adjustment. Convert that into the numerical form. Once that is converted, push it onto stack. Push of this symbol. We have got pushing that operand of type integer to stack. Suppose it is not the digit, it is the operator. What to do? You have to pop two symbols. That is OP2. The topmost symbol becomes operand 2. Below it is the operand 1. We got now OP2 and OP1. Call that function to perform the operation. That is, you are sending OP1 and OP2 to the function along with the symbol. If symbol is plus, the result of two operands, that addition will be returned, stored here. Return it. Returned value you have to push it temporarily. What you have got, temporary answer you have to, intermediate answer you have to push it onto stack. When no more symbol arrives, like in this case, after 1 or 2 plus no more symbol available, this part we have to stop, pop the last symbol and print. In this case, 3 will be printed. So this is the lab program that you can try. Thank you.